Okay, I heard the lady say recording in progress, so we are good to go. Thank you so much, Jangwo, for this wonderful invitation to speak to you all today. And thank you to all of you for coming on a perfectly serviceable Friday afternoon and evening, or wherever, as the case may be. I'd like to tell you a little bit about strategy in academic careers and how the concept of strategy applies to our three sort of mantra like goals of research, teaching, and service for the benefit of not only science and engineering, but students as well. So, some of these insights I sort of came up with recently as I have moved to the dark side, as they say, of academic administration. I'm now Associate Dean for students in the School of Engineering. And what that basically means is I get 100 more emails per day than I used to. And it's a challenge to work everything together. But I think by deliberately, thinking about how we can combine research, teaching, and service, we can actually grow the pie and be a lot more productive and deliberate in our choices. Okay, so teaching, research, and service, this is really a mantra in academia. So an academic's job is to combine these three sort of pillars in one way or another. And the first time I ever heard this was at a becoming faculty lecture while I was in grad school. And they put up a pie chart that looked a little bit like this. And they switched the labels around: teaching, research, and service, depending on what kind of an institution you were at. So in R1, like UCSD or Purdue, you might have the blue region here be mostly research, and then maybe red is teaching, and maybe green is service. But at a primarily undergraduate institution, or PUI, you might have the labels changed on this pie chart to emphasize teaching. And you could be at an R2, which would be like, say, the Cal State system, whereas the R1 might be the UC system in California. And you could have a pie chart like this at a community college that would be mostly teaching and then service, and maybe not very much research, depending on the particular type of position you had. Speaking of position type, so the employment type also has an influence on this type of chart. Whether you are teaching faculty or research-oriented faculty, whether you have a contingent position like an adjunct position, or a temporarily funded or soft money position, whether you're in the sciences or the arts and humanities tend to skew more toward teaching, regardless of what kind of institution you are in. And then in STEM fields, we have the additional requirement of mentoring that contributes directly to research, but is a kind of teaching. It's not entirely dissimilar to teaching. And the question is, can there be a logical relationship between these areas, or are they separate? And can our approach to teaching, research, and service strengthen our overall objectives in our job for impact and also fulfillment in our careers? And the hypothesis that I want to explore in this talk is that indeed, yes, it is possible to combine these three pillars of academic work so that we can actually grow the pie and do each one of them more effectively than we might do if they were chosen randomly. So this is sort of the typical arrangement. It's a Venn diagram that has no overlap, so it's just three circles. It's not even a Venn diagram yet. And let's say you apply to your job with a particular research topic. The department chair gives you a teaching assignment, say it's general chemistry or thermodynamics of materials or something like that. And it may peripherally have to do with your research, but not necessarily. You might have a grad elective that might have some overlap, but let's just say it's random. And then service, you might be put on some service committees like the space committee or the seminar committee, and maybe there's not very much overlap with the other two. Now, it's better if you can make an actual Venn diagram here where your research and teaching have overlap. Say you are researching, let's say, soft matter, and you teach soft matter. That's a good example. And then service. So say you are on exam committees of students who are working in an area close to your research interests, or your service role involves serving on the undergraduate affairs committee, where you can influence the types of teaching activities that go on in your department. The connection between research and service, so what lives in this part of the Venn diagram, is could be something like peer review for a journal. Say you are a soft matter researcher and you are an editorial advisory board member for the journal Soft Matter, just taking soft matter as an example. At an R1 institution, I alluded to this before, but your Venn diagram might look different. These are the relative weights of the different pillars of teaching, research, and service. If you're at an R2 or a PUI or a community college, it might look like this. And if you go back to just our regular Venn diagram, I gave you some sort of superficial ways that research, teaching, and service are combined. If you're on the seminar committee and you pick somebody that's going to write you a letter or that you could collaborate with in the future, then that's this part of the Venn diagram. But is there a deeper connection that one might make? Can you squish these pieces of the Venn diagram closer together so that there's even more overlap? And moreover, can you approach this problem in a dynamic way so that your research, teaching, and service are communicating with each other so that they feed into each other? They feed in and they augment each other so that all of a sudden the pie is much bigger and there become emergent phenomena that occur in your own career because you are able to not just combine these in a superficial way, but actually derive significant gain from the synergy between your research, teaching, and service. And this is kind of the aspirational Venn diagram. All right, so teaching, research, and service didn't come out of the blue. It is a deep part of the core of a university. So what is a university? What is a college? What is an academic institution or even a research institution? So what the purpose is to create, disseminate, and curate knowledge for the benefit of society. So that includes research, teaching, and archiving. I didn't say service because service is kind of how these things are actually done. So research, that's we'll talk a little bit more about what exactly research is, as if we don't already know, but there are some subtleties I want to talk about. So this last one, this curation or archiving, is a function of the university that is kind of like the stone walls of the place. In 100 years from now, when all of us are when I'm not here anymore, in 100 years from now, what will be the stone walls of this place that survive, even if the buildings are gone or all the buildings have changed? What is still here? The knowledge will hopefully still be here, and I thus would say that universities are the bulwark against ignorance and nihilism, and actually the fountain of civilized behavior. They are also the engine of the economy and of socioeconomic mobility, and And that is related to the fact that research is the creation of new knowledge, teaching is the dissemination of knowledge, and archiving is making sure that that knowledge lasts forever. Curation, archiving, lasts forever. To accomplish these things, you need service. And by service, we mean service to the department, service to the institution, service to the scientific community. That could be societies like AAASE, or they could be the Materials Research Society or the American Chemical Society, and that could be by scientific means, so peer review, or by governance or administration. So staff that is non-academic appointees of institutions fill many of these roles, but you really do need academic people in order to provide curricular, scientific, and promotional support of the institution. All right, research. Research is the creation of new knowledge. It usually involves something like the scientific method, where from elementary school you remember that flow chart on the wall, or maybe they showed it on a slide that had observation, hypothesis, experiment, and analysis, and the fact that the scientific method is iterative, it is self-correcting. Research is also forming connections between existing knowledge. So that's research and scholarship, scholarship being the formation of connections between existing knowledge, and the use of a research topic as a vehicle to train new researchers. So you might think that your research topic, maybe it's going to be 20 or 30 years before it has a commercial implication, but in the meantime, your proximate product is the knowledge and the training imparted on your trainees. And research is a wonderful way to train the next generation. Research also serves a business purpose at an institution, and it is also a proxy for status, for better or worse, in the form of publications, research dollars, and awards. Teaching. What is teaching? Well, we all know what teaching is, but let's think about some of its subtleties. So teaching is the dissemination or transmission of existing knowledge. And that is in contrast with what we do in a laboratory as a mentor, which is to help a student learn, or help a student learn how to learn, or help a student learn how to create knowledge. So what you're doing as a mentor is you're reaching into the brain of that student and you're fiddling with the knobs to get them to be more receptive to new information, and also making them better, helping them, guiding them, becoming better at generating new knowledge. There is also research on teaching, and a lot of us in STEM fields, I'm talking from my own experience, we were put in front of a classroom without any formal training on teaching, or even really that much awareness of the fact that there is a lot of research on teaching. And an example of research on teaching that has become very interesting to me lately is the neurobiology of memory and learning. Teaching in terms of what types of course content we cover runs from the fundamental to the theoretical to the practical to the vocational. Classrooms can be organized in a lot of different ways that have research associated with them. So we have conventional types of lectures, active learning. Sometimes this takes the form of flipped classroom approach. Flipped classroom being where you provide the students a video or a book ahead of time, and the students are expected to read it, and then they do problems and sort of the Socratic question and answer method in class, or they do group projects. And STEM folks were very pleased with ourselves for coming up with this flipped classroom approach, even though it's how every history, law, business course literature course has really ever been taught, but we can be kind of dense at times in STEM education. At least I can be. Okay, and then lately we've been hearing a lot about how our roles as instructors is teaching students how to learn. So sometimes this is called metacognition, teaching students to learn about their own cognitive style and how they learn and how they can motivate themselves to be more concerned with the material, how they can engage with the material to make it make more sense. Sometimes this is discussed in context of the study cycle, so how to bullet out a section in a textbook, how to ask questions about it that the textbook is going to answer later. How does this relate to something called Bloom's taxonomy or Bloom's hierarchy, which is sometimes shown as a pyramid? You have knowledge, comprehension, application, analysis, synthesis, and evaluation. And finally, the role of teaching is to help students develop as members of the learning community, how to induct them into the learning culture. Finally, service. Service is the thing that we all have to do to keep the system up and running, and that has to do with one of those tasks involve journal reviewing, organizing conferences and symposia at conferences, being on exam committees, so literature review exam committees, dissertation or thesis committees, service committees. So service committees might be serving on a board or a committee that decides the next editor-in-chief of a journal. It could be the search for a new director of student success in your department. And then also letter writing counts as service. So letter writing for your own students, I like to think of this like service after the sale. So when you buy a car from a mass market car dealer and you go there for service and they want to get you in and out as fast as possible, and they put you in that room with the stale coffee and you sit there while they do your tire rotations and whatever. But then if you get like an upper scale car and you take that to service, then it's like you're in like an airline lounge while they do the service on your car. And that's why this is service after the sale. Even if a student or postdoc graduates 10 years ago, like my postdoctoral mentor and Django's postdoctoral mentor, Dr. Shannon Bao, she is known for providing excellent service after the sale, always willing to support her former advisees even after we've been out of the lab for a long time. Then there are bigger commitments that you have mid-career. So you might be an editor of a journal, associate editor or editor-in-chief. I see some editors on this attendee list. Hello, please accept our papers. You see society administration roles being offered, leadership roles within the societies, university administration, so associate dean, associate vice chancellor, chair, whatever, and then also funding agency leadership. So you might be a standing reviewer for one of the funding agencies, a program manager, or a scientific review officer. All right, now let's talk on the, what are some of the ways that this is particularly for younger folks in the audience? How can research benefit from teaching? So how can your research portfolio benefit from your course assignments? The first way is that you can recruit students to your lab from your classes. For a long time, I had the best teaching assignments available in my department. I had the intro class for the nanoengineering graduate students, intermolecular and surface forces, which they all had to take, and I had the introduction to nanoengineering course for the undergraduates that they all had to take. And I got to know a lot of really excellent students, and many of them ended up joining my lab. You can also use the knowledge that you learn by learning it well enough to teach it to a class full of students to inform your research. Now, I think a lot of faculty go to remember being students, and they thought those faculty members, those professors, they really know that material. But little did we know that they spend a lot of time preparing for that lecture. And now those of us who are lucky enough to be in faculty positions realize how much time it actually takes, and the depth of the knowledge that the self-awareness of the depth of knowledge that we have when we're presenting. So I like to show it like this. I'm going to stop my screen share for a moment just so I can pantomime this. So this is the level at which we present our material, and then this is the depth of our understanding. And ideally, you're down here. So you're presenting up here, you have a lot of depth here, there's a big space in the middle where if a student asks a question, you will know the answer, right? But there are some times when unfortunately it flatlines, right? And if a student asks a question during this period, then you don't know. That's literally the only thing you know about that particular topic or that equation is what you've written on the board and what you've said about it. So it works in a couple of different ways. So a lot of times when you are learning something for the first time and you're fleshing out all of that depth of knowledge, some of that knowledge of which you're not going to use in the class, or even the knowledge that you are going to use in the class, you can use that knowledge and apply it to your teaching, especially if you ask your department chair to teach this class. I know it's going to be a challenge, but I want to teach this because I want to know the fundamentals of that area because they will be useful for my research. Moreover, the more you know, the more knowledge you have, the deep-seated knowledge that you develop as an instructor allows you to learn even more. So a good example of this, I have a favorite author who's an economist at George Mason University. His name is Tyler Cowen, and he's known for being a speed reader. And he reads, I don't know, however many 100 books a year. And somebody once asked him, how long did it take you to read that book? And maybe he read it in half a day or something. And his answer, 60 years, because he's 60 years old. And but the more background you have in an area that you've developed over a lifetime, or over a lifetime in a teaching career of teaching more and more different courses, the easier it is for you to pick up new knowledge because you can automatically draw connections, and that material is pre-synthesized in your brain, and it's very useful. And it's very useful to be able to take that knowledge and apply it to your teaching, especially if you are in a teaching assignment for a course that you didn't know anything about before. It does take a lot of time, but the payoff is often worth it. So in my own career, a couple of ways that this has worked out for me is that teaching intro to polymer science, I considered myself a polymer engineer, but I had never taken like undergraduate polymer science. And without that course, I don't think I would have had the wherewithal to accept students in the lab who wanted to do molecular dynamics. And if I didn't teach intermolecular and surface forces, especially the one lecture on friction and lubrication that we taught, I never would have hired audience member Charles Dong, who is a postdoc in my lab and is now a faculty member at University of Delaware. And our work in materials-based haptics probably wouldn't have arisen. Also, your students in your classes are a wealth of information, and you get to work with them as they develop their own ideas. So working with students in office hours can be an immense rich trove of knowledge and creativity, especially if you end up recruiting them to your lab. So you can kind of feed off of their energy. All right, how about the other way around? How does teaching benefit from research? Well, as a researcher, as somebody who is skilled in research, you know how to put basic concepts into practice, and you can take that knowledge into the classroom. There's a concept in teaching called teaching from the top down, which means basically that you create the bins for the material to go into. This is incidentally exactly the opposite way that general chemistry is taught, where you teach a bunch of obscure stuff about reaction kinetics and second order rate laws and Gibbs free energy, and then you don't connect it to the real world until you get into the research lab. But anyway, if you've been in the research lab, you can introduce the students to the bins. You know, the bin for commercial products that involve polymers, the bin for commercial products that involve electrochemistry, or the philosophical reasons for why you're interested in replication in biochemistry. So if you can create these buckets that rely on your experience in seeing a whole research field for all of the fundamental concepts that go into it, the easier it's going to be to convey to a student that there is a reason for learning the Gibbs free energy and reaction kinetics. You also develop confidence. Some experience in research and in the lab gives you, kind of breaks down some of that imposter syndrome that first-time faculty, first-time instructors might feel, that you are an expert and you deserve to be on stage. You can use specific pieces of information from the recent literature to update courses in real time. And finally, an instructor, even if, I'm sure we've all been in those classes where the instructor was very charismatic. There wasn't a lot of necessarily information content that was being conveyed in the course, but you really kind of wanted to be like that instructor. Like they were cool. They were a role model. They had maybe accomplished something in the research lab that made the news or that you knew about. And a lot of students will want to do the kinds of things that you are doing. And your presence, your research presence, actually has an impact in how some students will perceive you and will actually potentially alter their own academic and career trajectory based on their experience in your course. All right, let's move around the dial a little bit. How can research benefit from service? So there are some kind of cynical things that you could say here. One is to try to make committee service align with your research interests. So if you're pre-tenure and or say if you're a postdoc or a grad student and you have the opportunity to serve on a seminar committee or a student invited speaker committee, then you can get to know senior colleagues in your area, and they can get to know you. You can get to know program managers this way. You get to know future grant and paper reviewers this way, and future employers this way. For established people, you always need a letter to apply for this or that award or for promotion, and the seminar committee is thus a great way to learn. And also to collaborate, so that it doesn't all have to be like careerist, stuff. If you are on the seminar committee and you want to, go to a breakfast and a lunch and a dinner with a speaker, you can invite them, and maybe you can start a research collaboration that way. There are other types of committees, like the space committee, the teaching committee, that have similar kinds of synergies with research. So teaching, this is kind of a cross-cutting aim here. As I mentioned, teaching is also highly beneficial to research. And then graduate affairs and admissions committees, that's kind of self-explanatory. You get the first look at the pool of applicants. There can be division level committees that involve campus leadership. So for example, the School of Sciences or the School of Engineering or the School of Biological Sciences you might have the ability to see resource allocation in real time. You might see the nascent center grants and campus-wide collaborations and research initiatives that get launched and that you could have input in directing. You also become a better peer reviewer. So being a peer reviewer forces you to see what is at the absolute forefront of research, or at least what the authors think is at the forefront of research. And that's the same thing with reviewing abstracts at conferences. And so some of the most valuable but kind of annoying at the time experiences I've ever had have been being the lead organizer of an MRS or ACS symposium, because you spend a lot of time, going back and forth with the conference the conference staff and doing all the scheduling and everything. But when you sit down in that session, your commitment to that session makes you obligated to sit through a lot of talks in your field over the course of a week. And you get to see the gold coins of literally hundreds of papers. It's not just the papers that the researchers talk about, but it's also the first few minutes of every talk where they put the work that they've done in context and done the hard work for you of spelling out what has already been done by others in the field. Now, of course, you can get that just by sitting in a chair and going to a conference, but let's be honest, a lot of times the temptation to do email and to go on your laptop and to do some grant writing during a conference is very strong. At least it is for me. But when I'm a conference organizer, I pay attention to the whole thing, and I find that I'm better off for it. So taking a break from the Venn diagram now, how has my research trajectory gone? How have some of these findings found their way into my own work? So I started out as an undergraduate in organic synthesis and medicinal chemistry, and I had a project the summer after I graduated where I was using solid acid catalysts to affect asymmetric or enantioselective reactions to make beta amino acid precursors and polyketide type natural products, and that made me interested in nanoscale materials for heterogeneous catalysis. That led me to work with George Whitesides to work on the chemical origin of life. George Whiteside stopped responding to submitted work in that area shortly after I arrived, so I pivoted to organic electronics and organic photovoltaics. Now, this was still related to my initial interest in physical organic chemistry, physical organic materials chemistry. Part of this was because I started in my research group at the same time as Ryan Checky, Emily Weiss, and Michael Dickey, who mentored me in these areas. And then this led farther down this rabbit hole, right? So the next thing that I did was nanofabrication engineering in the service of making a better type of photovoltaic device. It worked like crap, but I still got a paper out of it and a lot of experience. And then I became interested, because of the nanofabrication engineering project involved cutting with a microtome. I became interested in mechanical properties of organic electronic structures. There was a grant opportunity available as a postdoc in the area of stretchable electronics. That led me to consider wearable bioelectronics while keeping the organic component constant. And then I became interested in what about materials, complex polymers, gave them mechanical properties that were amenable to wearable applications. So I began thinking about the dynamics of polymers and stimuli responsive electronic polymers, which led me to materials for haptics. Materials for haptics led me to an interest in psychology, specifically psychophysics, and human subject research in particular. And then I ran out of space here, so this is the next bullet in is written over here. And recently I got a funded project to work on molecular electrophysiology with a collaborator, and electrophysiology in particular of neurons that are responsible for tactile perception, again related to wearables, haptics, and psychophysics, and then finally behavioral biology. So we have another project on the use of haptic cues in wearable interventions in order to increase patient engagement and usability of wearable devices. So the project actually has nothing to do with collecting a physiological signal better than the last wearable sensor that was published, yesterday. It's really about how to use materials as a tool for manipulating behavioral biology so that we can get people to wear these devices more often. So that's kind of how this the research trajectory has evolved over time, and it's not unrelated. In particular, my interest in psychophysics, psychology, behavior, into why I went into administration on the student affairs and teaching side. So it started by accident. So when I started here in 2012, I inherited a committee assignment. So we talk about committee assignments and service and how the interplay between those and teaching and research. And I was assigned to the Idea Center Faculty Advisory Board, where the Idea Center is our Center for Inclusion, Diversity, Excellence, and Achievement. And it is kind of like the student support, student success office in the engineering school. And I became highly involved in the Idea Center. Several years later, I led the grad and postdoc scholarly talk series. So based on that scholarly talk series, it's similar to sort of what I'm doing now. I found a topic that I was interested in or that I was invited to present on, and I would give a talk on it. Then I started a YouTube channel with the scholarly talks and the course lectures that I also recorded as content. Now that YouTube channel is up to quite a lot of subscribers. And then finally, I was nominated on the basis of this work to be the faculty director of the Idea Center, which I served in that role for a little over a year. And the dean and the dean's leadership team sought to merge this role with the associate dean for students. And so since the current associate, or the previous associate dean for students, was stepping down at the end of her term, I inherited that job, and now I do sort of both of these jobs, although we're hiring some more staff to take some of the burden off of me. So now that's what I do. That was my route into into administration. It all started sort of by accident. So you might be curious what my day-to-day role is in this associate dean for students role. So I'm nominally responsible for curriculum in the School of Engineering, curricular changes. I'm responsible for the student experience. I'm responsible for time to degree and 4-year and graduation rates, getting those to be as close to 4 years as possible. And what do I do day to day? Well, I talk to a lot of people now. I talk to a lot of people, way more people than I ever thought I would be comfortable talking to as a fundamentally introverted person. And the job really is to seek pockets of creativity, energy, and capacity, and to find creative ways to extract value from these connections. So if somebody has a program on the other side of campus that I think could benefit engineering, and that engineering has a way that could publicize or benefit this program, then I try to find a way to connect these pieces. If there's a department program in one department that could be applicable broadly, we try to do that. A new project is to create engineering math modules, so video flashcards for engineering math that serve to be a sort of like a definitive concept inventory for civil engineering, chemical engineering, and so on. All right, so how do things fit together for me? So it all has to do with the human connection. So my research, teaching, and service have sort of coalesced. So organic materials, that's my core research interest. Organic materials chemistry, starting out as a chemical synthetic person, and then that led me to flexible electronics and haptics, work with human subjects. Now I know where we see a lot of human subjects, and that is in our, tongue-in-cheek a little bit, but in our courses and in our labs, and finding effective ways of teaching and mentoring using behavior, cognition, and learning, and then using what we're learning about behavior, cognition, and learning to teach about organic nanomaterials better than we could before. So in writing, so what I mean is in research, using organic materials as a tool to understand and modify neurobiology, including behavior, cognition, perception. And also this arose because of increased confidence in performing human subject research or in collaborating with individuals who do human subject research professionally. So in teaching, so intermolecular forces, that course that I taught for 10 years in a row, my course on polymers and nanoscale phenomena, taught using insights from behavior, memory, and learning, always trying to use literature and behavior and learning, and increasing, although still rudimentary, comfort with the teaching literature to become a more effective teacher of my research passions. And then finally, in the service realm, I'm interested in student success, broadly interpreted. So students who make it into the school should succeed in the school. They were all good high school students. There's no reason why they shouldn't be good college students. Closing equity gaps, using electronic resources, and compassionate use of behavioral understanding. So I should say that this is not double dipping. So I'm not saying that, I have engineered my service life so that I get to suck up all of the benefits from service and make my research stronger. Rather, this was kind of an exploitation of curiosity that led to this kind of circular benzene-like serpent biting on its own tail emergent phenomena that has this logic to it. So final slide, is this model replicable? Do I think that if I had to do this again, could I do it? You know, my career has a lot of years ahead. In 10 years, I'll probably be talking about some completely different things, but this is where I've arrived now. I'm kind of curious to know, like, if I step back and examine how things have gone, is it replicable? I think so. It does take a lot of time and deliberate development. So random teaching, research, and service assignments, you know, aren't really going to do it. You have to be a little bit strategic about which ones you select. And then I think if I were to start over as a assistant professor or even as a postdoc, I would try to pay, you know, more attention and interest to my own interests and curiosities and also skills and how they interplay. Talk to a lot of people, keep reading, keep learning, and work strategically. So when I was a postdoc, I took the course now called Stanford Ignite from the Stanford Business School. I think Django might have taken it too. Nodding. So it was super valuable. I learned about this concept called strategy, and I think we all kind of know what strategy is, but it helps to delineate the different compartments of strategy. And those are mission. What are you going to do? How are you going to spend your your whatever it is, 20,000 hours of work life doing what it is you're going to do? What are your values? What are your deep-seated beliefs about what is right? Scope is super important. What are you going to say no to? Because you've often heard it said that saying yes to one thing says no to 100 things. And that's really true. You need to pare down what you're going to do, and even if you're dean or department chair, you're a PI, if you're a student, shovels another project on the pile that you have to do. You know, sometimes supervisors like it when people stand up to them and say, I'm not going to do as good a job on what's already on my plate if I do that. Then finally, the teeth of a strategy is the logic, and this is exactly how it applies to combining teaching, research, and service. Is how are your activities in those three areas going to strengthen each other, and how is that going to help strengthen your long-term success? So these are just some ideas to get the creative juices kind of flowing, and I'm happy to have a discussion if you are interested. Thank you very much for your attention.
That is a fantastic talk. So there are a couple of questions actually in the chat, and before actually I introduce the question, I forgot to mention actually what AAASE stands for. So AAASE stands for Asian American Academy of Science and Engineering, and the mission of AAASE is to advance science and technology and serve the community and the society and empower next generations, and to promote inclusive justice. So we actually have the subcommittee on energy and materials. So you are actually our first speaker, and I think that it is a fantastic topic. So here actually a couple of questions. Actually, do you like me to read, or you actually can look at the chat yourself?
Maybe you can.
Okay, I can read it. Yeah, I can read it.
No. Otherwise, it'll be me mumbling and saying, "Oh yeah."
So there are a couple of questions here, and the first question actually is from Professor Xiaodan. Actually, he mentioned he found YouTube. So if you actually are interested in Darren's thoughts on various topics, you can actually go to his YouTube channel. It's very useful. And the second question was how to publish in good journals.
do good research. and
Oh, that's good.
and I think younger scientists tend to overstate the importance of the journal. I think there are a lot of reasons to publish a paper, only one of which is to have your name in JACS or whatever, Science or Nature. I have however many papers, and I don't have a paper in Science or Nature, but I did get tenure and full professor in relatively short order. So, how big a deal could it possibly be? But the most important, I think things to do when you're publishing, one, you want to make sure that the kernel of knowledge you put in the paper is good. It's going to survive. It's going to not be something that will be usurped by the next 0.1% of efficiency or whatever field you happen to be in. That what you're doing is contributing knowledge, not just numbers, to the field. And also that once you have this paper out, even if it's in Sensors and Actuators Q, you can then refer to it in a talk. And if you're in a talk that has 30 people in it, that paper that you're talking about is just as valuable on the screen as it is if it was published in JACS, or if you're writing about it in a grant proposal or a fellowship application. The fact that it's peer reviewed and it is this corpuscle of true stuff, we hope true, of true stuff, that you can refer to it, and it takes on a longevity and a seriousness that it doesn't have if it's not published.
Great. So here's another question about actually undergrad students. So teaching students sometimes help you to recruit new undergrad students in your lab, but sometimes undergrad students are hard to train. They might damage the experiment machine, waste your lab resource, and then leave the lab. To waste your time and impeding your research. I wonder, how do you deal with these undergrads? Or do you set up a high standard and choose undergrad students who want to do research with you?
Excellent question. It takes a long time and a lot of concerted effort to recruit anybody, whether that's an undergraduate or a graduate student or a postdoc, or an assistant professor for that matter, although I think most issues of breaking equipment are not that important for assistant professors. We like to shake the tree for a long time before we make the commitment to hire somebody. And by hire, I mean even just take on an undergraduate volunteer. So they will come to a few group meetings. They often will interview with multiple people in the lab to find the right project student fit. We have cases where the student has been in a class for a really long time, and like for the whole quarter or the whole semester, and you get a better idea of like what kind of conscientiousness they're going to have. But mistakes still happen, and they could start in the lab and they could be a disaster. So typically at the beginning, an undergraduate volunteer is on a probation system where they are not really a full member of the lab until the second term that they're in the lab. But that's a good question. Overall, I'm very happy that we've had the amount of undergraduate involvement that we have had.
Great. So there's another question from Lianbing, and he's asking, so could you actually talk a little bit about your thoughts on entrepreneurship in college education?
I'm a big fan of business training in college education and in academia. I think a lot of us as scientists and engineers tend to think that it's all BS and that it's all soft, fluffy stuff. But the fact is, you can have a technological solution to a huge societal problem, a technological solution that would work tomorrow, a good example being solar energy, yet its policy that is the reason that it's not being done. It's policy, it's politics, it's competing competing interests, and without the right business incentives, without the right tax structures, without the right investments, without the right skills and talking to the right people and saying the right words in the right order, none of that stuff is going to get done. And that's what business and management and entrepreneurship training does. To the specific, I think, implied point of like starting businesses, I think that can play an important role in academic research groups, not the least of which is that it gives a student something to do after they graduate, especially if it's their work that's being commercialized. It could be a source of unrestricted funding for the lab. If you look at labs that have been very successful in converting their intellectual property into royalties, but that is actually quite rare. Only really the top X% of labs have been successful this way. But also, if you're a faculty member and a student starts a company and you have an equity stake in the company as either a co-founder or a scientific advisor, you should probably be scientific advisor unless you're planning on giving up a lot of your time to be a co-founder. You could have an equity stake in the company, and if it has a liquidity event like an IPO or an acquisition, you can put that money back into the lab, right? Or buy yourself a solid gold car. but those are some of the ways that they might interplay.
Great. So there's a question from Yifan, and he asks that what actually is the most memorable thing you have learned from your mentee or students in the context of research and teaching?
Mentees and students can be rather unforgiving in their criticism. The classic thing is the student evaluations at the end of courses, and you can see 99 excellent teaching comments, and then there's that one that really stings. And if it stings because it's just mean, then you're upset for a few hours and then you forget about it. But if it stings because it's true, then those are the ones that stay with you for a long time. One time I got the comment that they might have even used the word engaging or charismatic or something during lecture, but that I did not provide a welcoming feeling when I answered questions after class or in office hours. And I was actually quite deeply hurt by that comment. And I think it was true. And it wasn't just true because I kind of felt that I sort of lost energy after the lecture, and maybe in office hours I wasn't giving it my all. But it was also because that was the second time I had heard that comment, and the first time I heard it was from our postdoc advisor, Chenan Bao, who said after one of my talks that your energy level goes off a cliff. I shouldn't just use those words, but after you gave that seminar and you answered questions very dry and like you were being defensive or annoyed to be asked a question. So I've thought about that very deliberately since getting that criticism. In the context of research, I recently went through a promotion process. So in the University of California system, we have these steps within each level, and I was going from professor whatever to professor whatever, n plus whatever, n plus x. And one of my mentees wrote in the anonymous comments that that the one-on-one meetings with this particular student weren't that useful because I was too I was too big picture and didn't help them enough with their day-to-day experimental design and how to solve particular problems. And in some cases, it's because I haven't really worked in the lab in more than 10 years, and I don't know exactly what, I don't know how to work the machine that they're using. But in many cases, I really could do a better job at internalizing the day-to-day struggles in the lab, and I've really taken that to heart and tried to improve along that axis.
Well, one of your mentee actually asked you a question, and it's actually from Rory, and she asks, when in your career you start formulating what your Venn diagram would be. What is a Venn diagram? Actually, I don't know.
So the Venn diagram is the circles that overlap.
Okay.
So they have gone through many iterations. I think giving this talk was especially fun for me because I didn't actually make a Venn diagram until a few days ago when I made the slides. But I had thought about it for a long time. I think that there had always I had tended to view my career trajectory in a more linear way. So I did this because I did this, because I did this, because I did this. And it hasn't been until fairly recently, especially with the associate dean role, that I've started to see my work in context and how it fits together. But I thought that if I had thought about this much earlier, I think I'd be better off than I am now. It might have seemed a little bit abstract, but it would at least have been a hypothesis that I could have tested. Like I would have said no to a lot more things earlier on so that I could have focused on, okay, this is how I'm going to arrange my research service and teaching activities. Good question. I wish I had a more
that is actually
satisfying.
I think your talk is going to help a lot of people. So.
Oh, thank you, Shangguo. Appreciate that.
So actually, Xiaodang actually asked you a question. Professor Xiaodang Gu from Southern Mississippi asked you a question about actually the funding. So do you see research and grant resource in a current funding environment is assigned efficiently and equally for all researchers? If you are a program manager, what would you like to do or manage your grant portfolio?
How much time do we have, as they
You
say? I'm joking a little bit, but there is a lot I would change about the funding environment. To answer the first question in a yes or no manner, no, funding is absolutely not distributed equitably. The top researchers who get the science and nature papers get, more and more funding. I think that their research proposals, when they come in, get a famous person premium. They get a prefactor attached to them, and it's a lot like how much easier it was for me to get a paper into Nanolet or Advanced Materials when I was a member of the Whitesides group or the Bow group than it has been as an independent investigator. And I'm not okay, you can take that as a complaint if you want, but it works the same way for grant review. It is unquestionably easier to get stuff in as an established investigator. If I were a program manager of NSF or NIH, I would put a lot more of my portfolio's budget into funding individual students. The first thing that would do is that it would spread the funding around more to away from the larger groups that might have reduced capacity because they would no longer have as much money for like materials, supplies, and recharge, so that smaller labs that where the mentors can be more actively engaged would have a greater share of students. The other thing that it would do is that it would reward investigators for being good mentors. So right now, there is no mechanism whatsoever in the NIH to determine is this PI going to grind their students to dust, or are they going to support them fully after they graduate? And if you empower students and postdocs more than the system tends to do now, they will gravitate toward the labs that provide good mentoring, that provide excellent service after the sale, and so forth. Another thing it would do is it would allow students to work on the problem of developing their own ability to select important projects, because they could work with their PIs to craft proposals that actually, meant something, because there would be some money that would come in as a result of them. And I'm not saying the whole portfolio, but of a program manager to be devoted to training, to be allocated to students and postdocs, but much more than tends to be done with the NSF GRFP, the NIH F32, and so on.
Thank you, Darren, and thank you actually for a wonderful talk and the wisdom on a number of questions. So since actually it's already pretty late, and thank you again. And just for the audience, this actually talk will be uploaded online and on probably YouTube channel as well. So thank you, Darren, again, and look forward to future interactions.
Likewise, Django, and thank you everybody for coming. This is really fun.
Bye.